Alright, something happened to my previous recording of this, so these are already filled out, but let me talk about them. So in relation to this chart here, when you're at your maximum displacement, you have your maximum force and subsequently your maximum acceleration. Your velocity is 0. This is what this part of the chart tells us. At our equilibrium position, when we have no displacement, we have no force, we have no acceleration, and our velocity will be at its maximum. For a pendulum, it follows the same pattern. So in a maximum displacement, or if I have my greatest amplitude, my force will be at a maximum and my acceleration will be at a maximum. My velocity will be 0. And then I have no displacement, or I'm at my equilibrium position. My force is 0, acceleration is 0, and my velocity is at its maximum. This is one of the pages we're going to be looking at the beginning of this week. There's some new vocabulary on here. Old vocabulary, harmonic motion and restoring force. There's some examples of what is considered harmonic and what is considered linear motion. New vocabulary are a cycle. It is one full motion, one full back and forth motion on a pendulum or a spring or a wave. Period is the time it takes to go this full cycle. And the frequency is the inverse of your period, depicted by this equation here. So your period is 1 over your frequency, and your frequency is 1 over your period. Just rearranging the equation. So these things are inversely related. The longer your period, the shorter your frequency, and vice versa. So this is the first time we're going to be looking at some graphs, a displacement time graph. Displacement from last week, we learned that at maximum displacement, you'll have the greatest restoring force. But we are going to look at it in the terms of the full motion now. So instead of just you weighing down a spring and the spring is stationary, we're going to talk now about the spring being in motion. So on the front is all this information. On the back is some practice. So again, I had already done a video and walked through this, but I'm going to show you anyway and talk through it even though it's already done. So marking one cycle in harmonic motion, you can go from a low position to the next lowest position, a high position to the next highest position, or you can go from an equilibrium position, one full cycle, to the next equilibrium position. Some students choose this middle part here, but it is half a cycle. So this is a half and this is another half, giving us one full cycle. So I marked 3 different sets of what one full cycle looks like. Starting at 0, where's the first cycle end? So starting here, we want one full cycle and we're at 3 seconds. Number of complete cycles, we've got 1, 2, and then some change. Our period we figured out to be at the beginning of 0 and ending at 3. So it's going to be 3 seconds long. Looking at this cycle here, 3 to 6 seconds, right? That gives me 3 seconds, right? From my equilibrium position, which is at 0.75, to my next end of the cycle, it gives me 3.75. Will still give me the 3 seconds. So using our equation that's on the front of this page, we can get 1 over our period to give us our frequency. 1 over 3 gives me 0.33 hertz. Our amplitude is going to be from our highest position to our equilibrium, or from our lowest position to our equilibrium. The equation on the front of this page gives it to you 1/2 your high minus your low.